You spent 10 days
Yeah.
underwater.
10 days underwater in the Aquarius habitat for Nemo 22 was my mission. That was back in 2017. And when you live underwater at,
When you
yeah,
live underwater, that's
yeah,
not a normal thing
you
to say.
become an aquanaut. And I think there's about 60 or 70 astronauts. Most astronauts in training now have to do this mission as part of their training.
Listen, you know that the health of our brains impacts every area of our lives.
Yeah.
And right now, in addition to that, neurodegenerative diseases have been skyrocketing in recent decades, and in particular, Alzheimer's disease. I was just looking at some of the statistics before the show today,
Yeah.
and it's creeping its way into the top 5
Yeah.
causes of death in the United States.
Oh, yeah.
And yet, most people have no idea of this kind of hidden epidemic right now. So, first of all, I want to ask you if you could just share a little bit about what is creating Alzheimer's disease from what we know with science today, and also what are some of the things that you've been doing and talking about and teaching about that can help to address this epidemic?
Sure. Yeah. Thanks for asking that. I've never really started off talking about Alzheimer's, but it is the very first project that I started with ketogenic therapies, right? So when we think about Alzheimer's disease, classically we think about our genetic destiny, is to have Alzheimer's, or if our parents had it or our grandparents had it or something like that. But we can be genetically predisposed to having Alzheimer's disease, but it's a very genes really drive maybe 5%, of
In the
Alzheimer's.
upper end.
Yeah, and that's being, some people will say 2% or 1%, or if you're ApoE4 positive, for example. But we know that prevention strategies will probably, have the biggest impact on this. So whatever is good for our heart is good for our brains, right? So our overall metabolic health will be a huge factor in influencing metabolic biomarkers that are tightly coupled to not only cardiovascular health, but whatever is good for the heart is good for the brain. So brain health too. So that is, things like keeping your blood sugar in check, keeping inflammation low, telling the doctor, hey, in addition to your CBC and CMP blood work, your comprehensive metabolic panel, to throw in insulin. I don't know, for some reason we don't measure insulin.
Yeah.
Throw in a simple measure of systemic inflammation like HSCRP, high sensitivity C-reactive protein. These two things alone, coupled with glucose, can be very important predictors of not only our metabolic health but our trajectory of getting age-related chronic diseases, including Alzheimer's disease. So this is upfront. This is a very important thing that people should know. That metabolic health will predict us getting age-related dementias, including in that Alzheimer's disease. So a hallmark characteristic of Alzheimer's disease is glucose hypometabolism, meaning that if you scan someone who has advanced Alzheimer's disease or even early dementia, what you see in a fluorodeoxyglucose PET scan, an FDG PET scan, which is a technology that can be used to look at the location and aggressiveness of tumors, but we can also image the brain, and it shows brain glucose uptake. In people with Alzheimer's disease, it's far less lit up, right? So it's much dimmer. So it's basically indicating that there's glucose hypometabolism. And the reason for that is largely unknown. And I think it's important to state right up front that the etiology of of Alzheimer's disease and other diseases that we study, like epilepsy, is largely unknown, right? So there could be multifaceted or multifactorial things contributing to Alzheimer's disease. But a hallmark characteristic is impaired energy production. So brain energy is impaired, and no one would dispute that. The reason that we have impaired glucose metabolism in the brain is there could be a wide variety of reasons. It could be the vasculature and the arteries that feed the brain energy, oxygenated blood and glucose, are impaired. So there's like a vascular component. There's also, we transport glucose into the brain through two different ways. At the blood-brain barrier, you have the GLUT1 transporter, And at the level of the mitochondria and the cell itself, the neurons, is the GLUT3 transporter. And then once the glucose gets into the cell to be used by the mitochondria to make ATP, ATP is the energy currency of the cell, that we need an enzyme called pyruvate dehydrogenase complex. So taking a step back, we know that it could be a combination of a decreased brain energy just through brain blood flow.
Mm-hmm.
So it's very common, people who have Alzheimer's disease that have a decrease in brain blood flow. It's very common for them to have, if you look at the GLUT3 transporter on the surface of the neurons, these tend to be internalized. So you have a cell membrane with a GLUT3 transporter, and that transporter can be inactive or it can be internalized inside the cell, so the glucose can't get in. And then once the glucose is in the cell, it requires pyruvate dehydrogenase complex, which is the gatekeeper and the rate limiting enzyme for glucose oxidation.
Right.
And
To
that
make ATP.
yes, and there's tons of papers. You can look at a PDH complex in Alzheimer's disease, that another hallmark characteristic is a reduction in the PDH enzyme and also in the total enzyme protein, but also a reduction in the catalytic activity of that protein. So even if we make it, it's not as active. So taking a step back, this is actually what got me interested in using a ketogenic metabolic therapy, nutritional therapy for Alzheimer's disease. So it was clear in the literature that elevating ketones through fasting, through the ketogenic diet, or even exogenous ketones can elevate brain blood flow by 30% or more. Simply fasting for 24 hours in naive subjects actually increases, you can do a Doppler blood flow measurement, and blood flow to the brain increases by 30%. And you could say, well, because you have less blood in the digestive organs, digesting food and things like that, so that could be it. But what's actually happening is that you have more blood in the reserves because you're not digesting, the blood is not in internal organs. But what also happens is that the ketone bodies actually stimulate adenosine. Adenosine is a vasodilator, and it increases brain blood flow. So transitioning away from a carbohydrate-based standard American diet to a state of ketosis will increase brain blood flow. The ketones bypass the glucose transporters. So for example, in glucose transporter type 1 deficiency syndrome, which is a genetic inborn error metabolism, the therapy is actually ketosis, the ketogenic diet, because the ketones then replace glucose as the primary fuel for the brain. So in Alzheimer's disease, you have impaired glucose transport by virtue of a reduction in brain blood flow, maybe a decrease of glucose across the blood-brain barrier, but very likely a decrease in glucose uptake into the neurons that is a result of an internalized GLUT3 transporter or an inactive, and a decrease in the total amount of pyruvate dehydrogenase complex, and the catalytic activity of that enzyme is decreased. All of these things that I just mentioned, which are basically encompass the hallmarks of Alzheimer's disease, can be overcome in a state of therapeutic ketosis. So with therapeutic ketosis, your blood glucose levels remain stable. The homeostatic mechanisms that maintain our blood glucose are very strong. So when you eliminate all sugar and carbohydrates, your glucose does not go to zero. It'll stay in the low normal range. But our ketones are elevated, and we know that the ketones can largely replace or supplement glucose as a primary energy source for the brain. So as we age, our brain has impaired glucose metabolism, but work done by Stephen Cunnane, for example, and others have demonstrated that as we age, the brain's ability to use ketones is maintained. So essentially what that means is that if
while glucose goes down.
Yes, while glucose goes down, because they're at the level of the neuron and the mitochondria, there are many more steps required to oxidize glucose for energy, ATP, than are required to oxidize ketone bodies for energy to make ATP. So that's why if you have pyruvate dehydrogenase complex deficiency syndrome or GLUT1 deficiency syndrome, the standard of care that we use, it's not an alternative therapy, the standard of care that we use is a ketogenic diet, because it bypasses the glucose dysregulation to supply the brain with energy and restore brain energy metabolism. But it's not only restoring brain energy metabolism. When you restore metabolism, you're also restoring the balance of neurotransmitters. You're also decreasing neuroinflammation. There are many energy dependent processes in the brain that function to keep the brain healthy. Included in that, and I put this towards the end because I think it's a downstream epiphenomenon, included in that is the accumulation of amyloid beta and tau plaques. So we are of the opinion that the etiology of Alzheimer's disease is incredibly complex, but there's without a doubt a metabolic component. So Dr. Mary Newport is someone who got me interested in this, and we were talking about her prior, and her book comes out, I think in November, called Keto Clarity, I believe, and I wrote the foreword to the book, just to plug Dr. Newport's book. But she was, there was a news article in the St. Pete Times, I'm trying to remember the date, 2007 or 2008. And it was the observation that giving her husband MCT oil and coconut oil together improved his performance in the mini mental state exam and also the clock test. He was being evaluated at the Bird Alzheimer's Institute at University of South Florida College of Medicine. And this made local news, and then it made national news. And then this is just when I was just getting interested in ketones as neuroprotective agents for Navy SEAL divers, right? So I saw that, hey, you could elevate ketones in the blood independent of diet by giving MCT and coconut oil. So Mary and I connected. Long story short, it led to a PhD project. Who now Dr. Milene Brownlow, she did her PhD at the Alzheimer Institute on a mouse model of Alzheimer's disease, which is tau and amyloid plaques. So these mouse models of Alzheimer's disease are not that great. So when people look at preclinical animal model research, you have to kind of view it with a grain of salt. Nonetheless, we saw a nice effect. In particular, we saw effect that the mice ran faster and farther on a rotorod device, which is like a treadmill kind of like device. So, and a really important problem with Alzheimer's disease is impaired motor function, impaired stability. They fall, they lose their function, their independence, and that's a downstream slope. So we saw very nice, effects across the board, but not so much on tau and amyloid when you start the metabolic therapy late, at least in a mouse model. But Dr. Dale Bredesen, and you could just go to his book or maybe have him on your podcast, he's done a lot of work in patients using similar approaches, ketogenic metabolic therapy. So, it was a long-winded way to say that Alzheimer's disease, the etiology is largely unknown in the medical literature, but there's a tremendous metabolic component. Yeah. Then the hallmark characteristics is impaired glucose metabolism, being in a state of therapeutic ketosis that can be achieved with time-restricted feeding, that can be achieved with ketogenic diets. I'm in favor of a modified Mediterranean style ketogenic diet that we can talk about, or you can use supplemental ketogenic agents like medium chain triglycerides, ketone salts or ketone esters can be used, or a combination of all these things to target brain energy metabolism. And Alzheimer's disease is characterized by the accumulation of amyloid plaque. So we think that that's more of a downstream epiphenomenon of the neuroinflammation, of the impaired energy metabolism, and the associated cascade of events that are associated with just an impairment of metabolic function in the brain.
Yeah, thank you for breaking that down, because when we hear impaired glucose metabolism, we don't really know what that means, and there's different levels to it. Yeah. And so having an alternative fuel source, essentially, it's able to bypass some of these processes that are dependent upon glucose, is really important, because as you know, one of the kind of blanket labels getting thrown on Alzheimer's now is type 3 diabetes.
Oh, right?
Yeah. It's kind of impaired glucose metabolism, but also sort of like an insulin resistance taking place in the brain itself.
Yep.
And this issue is, of course, has been growing and growing and growing. And I love the fact that you said the etiology itself is, it's complex, not exactly, we don't have a finger on it, but we know that this has a lot to do with our diet, our sugar intake, but also if we're talking about the buildup of these kind of, metabolic wastes and amyloid plaques and things of that nature, we've got we've got systems that help to clean house in the brain, for example, that
Yeah.
can get impaired from sleep deprivation,
Yeah.
right?
Oh,
So
sleep.
researchers, I
That's
think it was the
another thing.
University
Yeah.
of Rochester,
Yeah.
they found that the glymphatic system that helps to kind of clean
Mm-hmm.
out these metabolic wastes is 10 times more active, upwards of 10
Absolutely.
times more active when we're sleeping than
Yep.
when we're awake.
Yep.
And guess what another one of our epidemics is sleep deprivation in
Yep.
our society today.
Major contributor. Glad you brought that up. Yeah, because sleep is highly correlated with neuroinflammation in the brain and even gut. You miss a night of sleep and it's going to make your we were talking about zonulin, being activated, and that's a protein that's associated with the tight junctions. It maintains when it's released, it can cause leaky gut just by increasing paracellular transport across the intestinal epithelial lining, but also the blood-brain barrier. One night of sleep, if you are thrown into a situation where you have acute stress and epinephrine goes up and cortisol goes up, you can trigger injury, infection, inflammation, diet, all these things impact zonulin, which is, classically associated with the gut permeability, but we have those same tight junctions in our blood-brain barrier. And once that's compromised, you're releasing things into circulation, things that we study in the lab, like lipopolysaccharide or LPS. And these can cause, like, sometimes people will have a traumatic event or give a big talk and shortly after, or travel to a location and come back, and then they get a headache like the next day. That headache is likely gut inflammation, which contributes to inflammation and permeability of the blood-brain barrier, letting things into your brain, triggering a low-grade inflammation, and that can then trigger things like Epstein-Barr virus or herpes simplex virus or shingles or things like that, and then that can trigger an event that people have. But that's why we really focus on stress resilience.
Yeah.
So making the body, implementing metabolic-based therapies and other strategies to make the body more resilient in the context of these stressors. So the stressors that we study are extreme environments, the undersea environment, the altitude environment, and the space environment, and then also what we call like being task loaded. So we do a variety of psychological measures to understand why and how people get stressed and how to mitigate that.
Yeah, and your research isn't just theoretical. You are
Mm-hmm.
actually spending time underwater. Can you talk a little bit
Yeah,
about that? Because you just blew my mind when you shared it before the
yeah.
show.
Yeah, thanks. My research started doing, just taking a little bit of a step back quickly, patch clamp electrophysiology on neurons when I did my PhD, right? So you're looking at cells, individual cells. Then it led to animals, and then then it led to tissues, and then animal models, and then human clinical trials, and then ultimately what we call operational experiments, where we are the subjects on a IRB approved study by a federal agency, and in this case it was NASA's Extreme Environment Mission Operations, or NEMO, NEEMO. So I was on NEMO 22, and my wife was on an all-female crew of NEMO 23. So NASA uses an underwater habitat called the Aquarius habitat, which is off the Keys in Florida. And they bring astronauts to these habitats to train them on a variety of different things, including different operational activities that NASA has. It could be devices that are used underwater in the underwater habitat. So basically tools, techniques, procedures, and things are vetted out and tested in these space analog, what's called the space analog habitats. And NASA has quite a bit of, they got like at least a dozen space analogs. High Seas is one. We're involved in some of that, HERA missions. But the NEMO, NASA's Extreme Environment Mission Operations, is really the only space training, facility that actually uses astronauts. And 3 of those astronauts are on ISS now. Shel Lindgren, Samantha Cristoforetti is an ESA Italian astronaut.
So they're on
and Jessica
International
was,
Space Station
They're on
right
the
now.
International Space Station now. Yeah, they flew up in SpaceX Crew 4, which launched a few months ago. We actually went to the launch and got to meet them before, because we spent a lot of time training with them at NASA, but also inside the habitat underwater for 10 days.
Wait.
Yeah.
Say it again. 10.
Yeah.
You spent 10 days
Yeah.
underwater.
10 days underwater in the Aquarius habitat for Nemo 22 was my mission. That was back in 2017. And when you live underwater at,
Wait, wait,
we're at
just do
three
you hear yourself
atmospheres.
right now, Dom? When you
Yeah,
live
yeah.
underwater, that's not
Yeah,
a normal thing
you
to say.
become an aquanaut.
Yeah.
And I think there's about 60 or 70 astronauts. Most astronauts in training now have to do this mission as part of their training. And 24 hours underwater, you become an aquanaut. And that basically means when you go recreational scuba diving, you dive under and then you have to come up in a predetermined amount of time according to the no decompression limits, right? So you don't want to have to go into a hyperbaric chamber or you can die. So if you're underwater and at 100 feet and you stay down for 3 hours and shoot up to the surface, you're going to die a very painful death from decompression sickness. It's also called the bends. When you live underwater, you are living in a state which is called saturation. So you're breathing the gases, and those gases equilibrate with your body. So your body is retaining a lot of nitrogen and a lot of oxygen. And it's also the CO2 concentration. We're breathing 300, or now it's a little bit higher, 400 parts per million of CO2 now. But in the habitat of the International Space Station, or in the space training analog, it's about 3,000 to sometimes it went up to 8,000 parts per million of CO2, and that's considered hypercapnia. And when CO2 levels rise, it equilibrates with your body, and it actually hits these tight junctions and makes your leaky gut. And I tested my urine for neurotransmitters, my blood, my saliva. I looked at hormones. And the thing that jumped out is oxidative stress goes way up. And my C-reactive protein, which is always like 0.1 or non-detectable, went up to like 6.5 or something like that. That's because these extreme environments impact things like the gut microbiome and the integrity of the epithelial lining of the gut, but also the blood-brain barrier. So we have to understand, what happens when you put people in these artificial habitats, and you could say an office is like an artificial habitat with elevated partial pressure of these breathing gases, because we have to send people to Mars and back and bring them home safely. We need to create countermeasures to enhance their safety and resilience and performance in these extreme environments. And that's a big part of what we do in our lab, but also outside of the lab. In collaboration with Duke, we have some studies too, but also as test subjects ourselves, and also principal investigators on various things. We vet out different procedures. And something that we think is very important is optimizing our physiology to improve our brain resilience and our overall longevity, in these extreme environments, which are very pro-oxidative, pro-inflammatory.
This is so fascinating, and there's two things here. It speaks really to the resilience and
Yeah.
adaptability of humans.
Yeah.
And also, when we think about these extreme environments, we're talking about this kind of external environment. And even now, we're in this kind of artificial, put
Yeah.
together scenery
Yeah.
setting. And, the thing is, even as I say that, I realize that we are part of nature as humans, and the stuff that we create is
Yeah.
still nature.
Yeah. Yeah.
But when we start to pull away from our, the circadian patterns and all these different things, we start to alter what
Yeah.
our genes are doing, which we talked about before
Yep.
we got started too. So I want to circle back and talk about genes in a moment. But the extreme environments we're thinking about externally, but what
Mm-hmm.
we're also doing as a culture is creating these extreme environments internally with our
Yeah.
food,
Yeah.
for
Yeah.
example. And then we can have external manifestations of that, which for
Mm-hmm.
you was eczema, was something that you
That's right.
struggled with for a
Yeah.
long time. Can
Mm-hmm.
you talk about that and how you
Yeah.
resolved it?
Yeah. Yeah. Yeah, that actually brought me to the field of nutrition. I was not a good student. I was like in classes that were, that they put the dumb kids in, kind of growing at a very young age. And then as I got increasingly interested in biology, I was doing a little bit better. And then in high school, took like college biology. And by the time I finished college, I was like a fairly good student, but not great. But because I got very interested in uh, biology, because I wanted to enhance my strength, in working out and nutrition, and that was a big aspect of it. But I learned that as I changed my nutrition, my eczema, which is something that I dealt with for many years, in a few cases, I remember playing football where the eczema got irritated and it led to something called impetigo, which was like a staph infection and stuff. And this happened a couple times. And It was just no matter what creams, if I used corticosteroids and put them on, they would work for just like a week or two, and then they would have this rebound effect. Then they would stop working, then I would stop using it, and then it was worse than when I was using the steroids. So I struggled with this constantly until I started studying nutrition, and I think it was Barry Sears came out with a book in the early 90s called The Zone Diet. And then, I started reading a little bit more about this, and I majored in nutrition as an undergrad, and I just simply removed processed grains and went from a lot of pasta and bread. I grew up in an Italian family, and we, who still eats pasta, but I phased that out and kind of replaced it with sweet potatoes and brown rice and things. And then it got tremendously better. I started eating more fish and fish oils. And then occasionally I would reintroduce grains and other things back in, and bam, the eczema would come back like within about a week or two. So I repeated this experiment a couple times, if you want to call it an experiment, and it validated in my mind that this was a trigger. But this is before I knew anything about zonulin or gliadin, or and all the factors that could be influencing the immune system, the gut and the immune system. So that sparked my interest, in addition to the fitness, being very interested in fitness and weightlifting, into how nutrition could be used to treat an autoimmune. I became a believer even before people were talking about using nutrition to attenuate or even completely abolish, autoimmune disorders. And that set me on a path for thinking about nutrition as the primary lever to pull for our overall health. Not just, metabolic health is tied to brain health, cardiovascular health, and everything in between. So as I went down the nutrition path, I wanted to go to medical school, and I thought the general consensus was that nutrition was kind of like a soft science.
Right.
So I double majored in biology too, to get that under my belt. And then the 90s was the decade of the brain. So I got steered into a neuroscience and physiology program instead of a nutrition program. I'm glad I did because I think it was a little bit more rigorous at the time. Although if I was to go back in time, if I was to go back into college now, I'd probably study nutrition and just study nutrition. I would study nutrition and neuroscience on the side instead of neuroscience and nutrition on the side. But when I would go to national conferences like Experimental Biology or Society for Neuroscience, I would gravitate right to the nutrition stuff. So I would, at Experimental Biology, I was a physiologist, but I would actually look to see, hey, what's on the nutrition, what's being presented, and I would go to all the nutrition things. So I had this passion for nutrition. And then ultimately, my postdoctoral fellowship was basically designing nutritional strategies for oxygen toxicity seizures, which are a limitation for Navy SEAL divers when they use a closed-circuit rebreather, and that ties into our underwater mission with NASA and everything. But yes, that was a little bit of a circuitous theme, but it really, I think it may have started with the eczema, because I was reading at the time Muscle and Fitness and other things. I would always read the little nutrition things here and there, and it was giving me clues that nutrition was a major player, in our skin health and our immune health and things like that, and then overall inflammation. So Barry Sears' book talked about eicosanoids and prostaglandins and how to engineer your diet to reverse this pro-inflammatory state, and that was really the stepping stone for me. And then I kind of I would talk to my professors in nutrition about this, and they kind of rolled their eyes because there wasn't really a favorable outlook. It was always about low fat, keep fat as low as possible, keep the carbs high,
healthy whole grains.
Yeah, healthy whole grains. Yeah.
Yeah, I had the same experience, of course, going to conventional university.
Yeah.
And, but this your story speaks to the power of our psychology and how that influences our results. Because for somebody to hear coming into this that you were a poor student at some point, when you are one of the foremost brilliant thinkers in this field today, it's just really remarkable. But you got tied into that because of a passion, because of an interest, because of a real world effect for you. And you kind of fleshed out your inherent genius through that experience. And I want to ask you about this.
Absolutely. It's like your experience too. Like you immerse yourself, and you can't, you can't manufacture enthusiasm. So you need to be limbically, emotionally motivated on a subject to really do your best. Otherwise, you're just kind of manufacturing enthusiasm. It's only going to take you so far. But you have to,
Absolutely.
that's what I tell my students. It's like, well, they could have the best CV or resume in the world, but I was like, what? I try to find out what internally motivates them
Yeah.
and then put them in that position. So I think that's what led to it. I found out what I was very interested in.
Now here's the rub. There's this really interesting interaction that I don't know if you've really thought about this, because you have that passion piece,
Yeah.
but then you actually started to feel better, right? You start to
Yeah.
get results in the real world. And when you marry those two things together, it's remarkable what happens. And this leads into this conversation today about mental health
Yeah.
and just being able to actually do some of the things that we're talking about.
Yeah.
And it's when we start looking at some of the statistics right now, it's mind blowing. The leading cause of death right now, currently, for people between the ages of 18 and 45 is drug overdose right here in the United States. And people don't, we see that and we think, of course, we have this tendency, this bias of like, oh, it's just these drug users, this kind of thing. And we fail to realize, like, what are the underlying mechanisms that drive people towards this behavior? Oftentimes, they're trying to self medicate or medicate through the collective agreement with their physician as well.
Yeah.
Because even with fentanyl, that's the number one
yeah.
killer, by the way. When I say drug overdose,
Yeah.
specifically from fentanyl, right?
Yeah.
And so we're medicating, we're dealing with pain, physiological, psychological pain that we're trying to address. So, what I want to ask you about is how your work and even a ketogenic diet plays into helping to address our mental health. Because I think a big driver, just one of those foundational things behind our struggles with mental health, anxiety, depression,
Yep.
ADHD, has a lot to do with our diet.
Yeah, I'm glad you brought that up, and nice segue from, kind of following your passion. Because when you follow a nutrition program, not only does it change your physiology, but that physiology changes your mental state, right? And that's I became very interested in this idea, which was brought to me by a couple people were key influencers that more academics, not influencers in the conventional modern day social media sense, but they influenced me to an amazing degree. Dr. Jung Rowe, he did a lot of work showing that ketogenic diet can change your metabolic physiology, which changes your brain neuropharmacology. So that work led me, it was actually email communication through him that I sent to a Department of Defense program manager that ultimately ended up in my funding. So he changed my mind on that. And also there was a patient in the UK that had epilepsy, and his name is Mike Dancer. And if you Google Mike Dancer epilepsy, you come up with a very interesting story. And he was sort of in the fitness world too. And the ketogenic diet not only controlled the seizures, it significantly improved his mental health. And I realized I could see that just from the back end, that the ketogenic diet was an effective metabolic therapy that had good science behind it for 100 years now. And that it was doing it by changing the neuropharmacology of the brain in a way that changes neurotransmitter systems. For example, more glutamate is converted to GABA, and GABAergic drugs, as you know, benzodiazepines, Valium, Xanax, these are anti-anxiety drugs, right? And we've seen this in our experimental models too, that if you induce a state of therapeutic ketosis, and that could be with fasting, that could be with a ketogenic diet, or it could be with supplemental ketones to elevate ketone levels in the blood and in the brain. There's a greater activation of an enzyme, GAD65 and 67, I think, that convert. This is glutamic acid decarboxylase. That's how we make neurotransmitters. So we make glutamate from alpha ketoglutarate, and then the glutamate then becomes GABA. Glutamate is an excitatory neurotransmitter. And when we have epilepsy, when we have Parkinson's, Alzheimer's disease, traumatic brain injury, we have an excess of glutamate in the brain, and that causes hyperexcitability and neurotoxicity in the brain. So what the ketogenic diet does is it balances, and this is just one neurotransmitter system, but it does it to multiple systems. It converts more of that glutamate, which is hyperexcitatory, to GABA, which is very calming, right? So that's why vigabatrin, for example, is a anti-epilepsy drug. The benzodiazepines, hits the GABA receptor, GABA-1 receptor, or GABA-A. So in doing so, it became very apparent to me that the ketogenic diet was a legitimate medical therapy for epilepsy. Controlled studies by Mayo Clinic, Johns Hopkins, specifically Dr. Eric Kossoff and Mackenzie Cervenka are leading the way. They were mentored by the late John Freeman, who really spearheaded the use of the ketogenic diet at Johns Hopkins to develop that neurology ketogenic diet program there. And then there was a movie about the ketogenic diet by Meryl Streep, and that really led to advance the visibility of the Charlie Foundation with Jim Abrams, who's here in Hollywood. He lives, and he inspired me, and I incorporated Jim into the TEDx talk that I gave a long time ago. But it was really, I knew in the back of my mind that the ketogenic diet it's the only diet, there's no other diet that you can follow that actually stops epilepsy. You can, if you do a Mediterranean diet, a low-fat diet, or any other diet, and even reduce calories, create a caloric deficit, it does not change brain neurotransmitter systems to control seizures. So the ketogenic diet does that, and that's a very unique feature, and that's what makes it a metabolic therapy. So in many cases where you have a psychiatric disorders, and this is sort of the segue to brain health or mental state, when you have a psychiatric disorder like bipolar, for example, patients are often put on anti-epileptic drugs to control the manic episode, to control various aspects of psychiatric illnesses. And it kind of made sense, and this is sort of further validated by the work of Chris Palmer at Harvard and Dr. Shabani Sethi at Stanford, who really coined the term metabolic psychiatry. And there's a big movement right now being spearheaded and funded by Jan and David Bazuki that is basically putting funds towards answering this question. Does nutritional therapies like the ketogenic diet as a metabolic therapy change brain energy metabolism and neurotransmitter systems to basically advance this entire field of psychiatry and to give, because psychiatric drugs are not working in many cases. Bipolar, schizophrenia, depression, these things are very complex disorders. The etiology of these things are largely unknown. With schizophrenia, there's a genetic component, but not so much with bipolar, not a whole lot with depression, but other things, there's a genetic component. So we know that neurotransmitter systems are being hit by ketogenic diet therapies, and through brain energy metabolism, through the gut microbiome, through reducing neuroinflammation, and just by changing and losing weight. If you have patients, and in this case, you could use any diet and take someone who has depression, anxiety, schizophrenia, and get them to lose weight. It's going to change metabolic biomarkers like insulin, glucose, inflammation, and other things that would improve their psychological state and how they feel about themselves. But the advantage of using the ketogenic diet is that it has a much more profound effect at changing the brain chemistry and stabilizing neurotransmission in a way that has particular efficacy at controlling the manic episodes associated with bipolar and probably the depressive episodes too. So there's a big movement being spearheaded right now by the Bazuki Brain Research Fund, in large part through the efforts of Dr. Christopher Palmer, who has a book coming out in November called Brain Energy. I have an advanced copy of that, and it's great. I think you should have him on. So he's really advancing this, as is a number of investigators. There's a big group that's expanding very rapidly. There's about 24 people involved in this group, including Dr. Jeff Volek at Ohio State University, who's been doing ketogenic therapies before when I was even in grad school, and didn't even know the ketogenic diet was sort of used outside of the world of epilepsy. So keep your eye on this field of metabolic psychiatry. And I think that once the research is conducted and published and accepted, we will have a very powerful tool in the toolbox that will be hopefully embraced by the medical community, by psychiatrists who may maybe rebrand themselves as metabolic psychiatrists, because this is a rapidly expanding field in research, thanks to some generous funding organizations through the Bazookies, who are supporting an aspect of our clinical trial using continuous glucose monitors, and to look at metabolic optimization. And a component of that study that is also being spearheaded with partnership with Dr. Allison Hull of Florida Medical Clinic. We are looking at mood. We are looking at sleep. We are looking at various aspects of mental health by putting continuous glucose monitors on patients and coupling that with a low-carb ketogenic diet in non-diabetic patients. So just taking the average everyday person who is not necessarily have diabetes or any overt medical condition, and optimizing their nutrition, putting a wearable device on them as a behavioral tool, and then looking at not only a whole bunch of metabolic, cardiometabolic biomarkers, but also looking at your psychiatric biomarkers and mental state. So we think that the data coming out of that right now is not published. We've published it in abstract form, but we're analyzing a lot of the data now. But for one thing that really jumped out was non-alcoholic fatty liver disease. So patients who were not obese, patients who did not have type 2 diabetes, when you put them on a low-carb diet, it reversed their hepatic steatosis, which is fatty liver. But what was really surprising is that they did not know they had fatty liver disease until we scanned them, because it doesn't show up in the liver enzymes. And that's an ALT may be slightly elevated, and that's like an early, but once your liver enzymes are above and outside the normal range, then you're getting fibrosis in the liver.
Right.
So
It's
it's like
too
hard
late.
to reserve. Yeah. So you have to do, we tried to propose a CT scan, but that's radiation, and the IRB didn't like it. So we got a team that does very high resolution, ultrasound, and we could image these. And people thought they were totally fine. They didn't have diabetes, they didn't have any kind of irregularities, but they had fatty liver and the precursors to a potential fibrotic fatty liver that would be potentially irreversible.
It's another one of those hidden epidemics, fatty liver.
Yeah,
And
it
also,
is.
you've mentioned neuroinflammation several times. There's
Yep.
certain things that until we actually see symptoms, like it's so far gone. But you mentioned this continuous glucose monitor.
Yeah.
And also you mentioned someone at the Ohio State University as well. And
Yeah.
it reminds me of a study, because with the ketogenic approach, we have a viable tool for improving mental health through that lens of, as you mentioned, changing neurochemistry, but also simply stabilizing blood sugar.
Yeah.
Because that is one of those, right now in the United States, we're knocking on the door of about 130 million citizens have type 2 diabetes or prediabetes right now. So chronic issues with blood sugar regulation. And there was a study that was done at the Ohio State University on married couples.
Uh-huh.
And what they did was they gave them some devices to monitor their glucose, and the scientists were able to track this and stay on top of their data. And throughout the day, what they found was that when couples' blood sugar was dysregulated, they were more likely to have arguments with their spouse. And here at the end of the study, they were far less likely to resolve their relationship conflicts when their blood sugar was dysregulated and dysfunctional, right? So again, we have another tool here to supplant, because it's not just the fact of the ketogenic approach helping with the neurochemistry, it's pulling out that major culprit, which is ultra processed foods, likely high in sugar and high in ultra processed carbohydrates as well.
Absolutely. And I was telling you, I'm at the Ancestral Health Posium, and Dr. Robert Lustig it has a lot of insight in this, and a lot of experience in treating patients and everything. And that's really like I think the low hanging fruit. I mean, especially sugar laden beverages, which are essentially like giving the body, it's liquid candy, and it's like giving the body an IV bolus of glucose, really. Actually, it would be less dangerous giving an IV bolus of glucose because you'd have less of an insulin response. But when that bolus of glucose hits the gut, it's immediately absorbed and enters circulation and has a profound effect on our gut hormones, not only our gut hormones, but the neuronal circuitry associated with eating behaviors, and triggering, for example, a dump in dopamine, which you're going to then go seek more dopamine when you spike dopamine through these repeated glucose boluses. So not only it's not just an empty calories, but it's actually how these things affect brain chemistry and our gut microbiome and things like that. So this has to be recognized, and he's done a lot of work. So sugar delivered in the form of a liquid bolus is much more atherogenic, causes much more metabolic damage than sugar delivered in processed foods. They're both terrible, but the sugar delivered in a liquid bolus is on the order of magnitude of almost double of what you get, depending on the food that it's incorporated into, just because of the metabolic response that's associated with consuming a liquid bolus of sugar. So, and that's really the low-hanging fruit. I think we just need to educate people around that. But you go into impoverished communities, and that's all you see on the shelves. That's all people are buying because it's cheaper than the water, right? So you go to areas where we've done sort of education camps like West Virginia or like parts of Appalachia, for example, and that's all they drink is just Mountain Dew and Coke and things like that, and they give it to their babies, instead of formula, and that's causing diabetes in infants before they even have a chance, in life. And that's
this
really
is not a joke. I've seen this in baby bottles. In my family.
Oh, really? In your family?
Of course, yeah. Wow. Like one of the first things that we do, like when a baby can hold on to a McDonald's French fry, you know what I mean? And it's just a part of the culture. We don't realize that food has these impacts. And yet we have, 90% of family members having some form of chronic disease and upwards of 80 to 90% being obese. But we don't realize, like, this is the thing about exposure, right? And making information like yours accessible and just frameworks of eating. Like, one of the things I really enjoy about a ketogenic approach is the fact that it gives a framework, right? So you know that these things are not a part of this. And it's just that in of itself is so nourishing and healing, versus just trying to micromanage calories while still including these processed foods or like soda and things like this. Just that one action of taking out this liquid barrage of sugar can be so changing for our metabolism, for our brain. The list goes on and on. And I want to ask you about this because we've circled around this several times. It was researchers at the Albert Einstein College of Medicine. They published some really fascinating data recently, and they were looking at neuroinflammation, and they felt that it was a double-edged sword of nutritional diseases, that our epidemics of neuroinflammation is contributing to insulin resistance and obesity, specifically adiposity of the gut. And adiposity of the gut, insulin resistance, was creating more neuroinflammation, right? So having excessive body fat was creating inflammation in the brain. And it's creating this vicious circle. And people might think, well, my how do I know if my brain is inflamed, right? It's like our brain is so protective, and not particularly having even pain receptors in the brain itself, because the brain is responsible for telling you and managing pain in other parts of the body. But when the brain is hurting, we often don't know until it's too late. So let's talk a little bit about neuroinflammation and how we've touched on a little bit how it's being created, but what are some of the things we can do to reduce this neuroinflammation? So you talked about adipose tissue causing inflammation, and we know that
one thing that comes to mind is that adipose tissue is an endocrine organ.
Right.
When I was in nutrition studying in the 90s, we didn't talk about our fat being an endocrine organ, releasing adiponectin and, of course, leptin. As we lose weight and we get super lean, then our leptin goes down like proportionally, and that sort of can factor and trigger other things and influence things like neuropeptide Y and ghrelin and cause us to eat again. But that's why everybody has a set point. But I think that set point can be changed. But getting back to this theme of neuroinflammation and adipose, the best thing to do to reduce neuroinflammation is really to focus on, and I don't want to sound overly simplistic, but basically doing a nutritional and exercise approach, because I think nutrition needs to be coupled with exercise for maximum, to alter body composition. So as we get a more favorable body composition alterations through a nutritional intervention, it doesn't have to be a ketogenic diet. It could be ideally, like with older people, high protein, moderate fat, high fiber. So instead of low carb, I like to say high fiber. So just incorporating fibrous carbs like vegetables. And I know there's a little bit of a backlash maybe in the carnivore community about eating vegetables, things like that. But I definitely think you would have a very hard time arguing about the benefits of fiber. There's just so much information like on that. So first things first is just focus on optimizing metabolic biomarkers, and that would be your glucose levels, your insulin levels, which you should request getting measured, and also request simply a marker of inflammation, high sensitivity C-reactive protein. Systemic inflammation is tightly coupled to neuroinflammation. If you have inflammation throughout your body, and you don't have to do a full cytokine chemokine panel, but I think high sensitivity C-reactive protein is really core. The more data, I used to think very loosely about this. Oh, it's just a non-specific marker of inflammation. But the more studies that are coming out really are showing that your mental health, the state of inflammation, your even things like epilepsy, epilepsy and cancer are tightly linked to the level of systemic inflammation measured just with one biomarker, HSCRP. So optimizing our nutrition to eliminate processed sugars and reduce overall glycemic load will pay big dividends when it comes to reducing systemic inflammation, neuroinflammation. And I think something needs to be said about total calories, right? So any diet you follow, if you reduce the calories and create a calorie deficit, even, I hate to say this, but even in a processed food diet that's primarily processed food, but just reducing total calories, and you could do this through time restricted feeding and intermittent fasting, is going to produce some favorable changes. But the changes will be exponentially better if you improve the quality of your diet. So instead of just the quantity, it's important to create a calorie deficit, but the easiest way to create a calorie deficit is to improve the quality of what you're eating. It becomes astronomical because it's not overtly triggering neural circuitry that's making you want to eat, and
Right.
it's reestablishing metabolic flexibility and metabolic control much easier. So optimizing our nutrition, measuring these biomarkers, and really focusing on what I like to call just like biometric biomarkers or functional biomarkers. Like, if you can do X amount of push-ups and chin-ups or whatever, and I saw your push-up challenge with Gabrielle the other day. So, and that was impressive. If you can do that.
I'm not doing it with you. You've been underwater for 10 days.
Well,
And you exercised underwater too, didn't you?
well, yeah, we did. That
Of
was
course
part
you
of
did.
what we had to do.
Of course you
Yeah,
did,
yeah.
Dom.
So, but just improving upon our function through exercise, primarily resistance training instead of aerobic training. Resistance training will pay the biggest dividends because you're building skeletal muscle mass, which increases not only skeletal muscle mass but bone density, and that it's that skeletal muscle mass which is the glucose sink. So our metabolic health is tightly coupled to the amount of muscle we have and us using that muscle. And I think that's going to reduce inflammation tremendously, just having more control, like metabolic reserve, if you say.
Awesome.
Yeah.
That's I'm so glad that you tied that together.
Yeah.
You know,
And
we've
I,
talked about go ahead.
yeah. And, that was a little bit oversimplistic, but I think we're still we don't fully understand what is triggering neuroinflammation because, there are some people doing everything right. There are some people who have nailed their nutrition, some people who've optimized their diets, and some people who look like physical specimens, but they still have neuroinflammation. So in this case, I think it's important to look at the potential for a pathological agent causing this. So this could be a bacteria, it could be a chronic virus. So
Could be an intoxicant.
it could be a toxicant, so that was the next thing. But I would urge people to, especially if they're in like the Northeast or anywhere really, to get like tested for Lyme's disease or to look at like Epstein-Barr virus or CMV or herpes simplex virus, or if you're older, to get like a shingles, to get tested for shingles, and that because some people, and it seems to be more prevalent in post-COVID, and I don't want to kind of get into whole that discussion, but it seems like our immune systems are sort of hyperactivated now in a way that is triggering or increasing the pathogenicity of these chronic microbes that we may have. So that's an area of research that we're very interested in because there's some compelling data to basically link some of these viruses to Alzheimer's disease. So viruses can cause chronic neuroinflammation, herpes simplex virus, Epstein-Barr. There's quite a bit of research on that, and potentially Lyme's disease too. So it's a very, I was going to say nascent field, but people have been studying this for some time, and there's good data accumulating that points to various infectious agents as being triggers for neuroinflammation. And I would then go back to that once you've dialed everything in and you're optimizing as much as you can, but you still have sort of chronic headaches or neuroinflammation or these episodes, you might want to look at various infectious agents causing that.
This is still pointing us to a place of empowerment. What can tend to happen even with the outcomes coming from viruses, which there's some data even COVID finding its way into the brain, is that there's nothing we can do about this. And even when you started off the conversation with Alzheimer's disease, again, knocking on the door of being in the top 5 causes of death in the United States right now, 6 or 7, and less than, if you put together some of the best data on this, less than 5% of this is due to true genetic defects. A lot of this has to do with our environment, our lifestyle, and the like has a huge influence. The same thing holds true with the expression of infectious diseases and viruses and the like. Why are we seeing this happen right now at this degree? We're, as a society, we're the sickest nation truly in the history of recorded chronic diseases specifically in recorded human history. Our epidemics of obesity and insulin resistance and cancer and heart disease, the list goes on and on. It's creating a state where we're far more susceptible to these things. So it's the opposite of resilience, right? So our bodies being able to manage, because as you've mentioned, these viruses, the majority of people carry some form of like a herpes virus, for example. And it can manifest due to these stress inputs. And the stress, now when you're stacking conditions against you with stressors, be it from your diet, emotional stress, environmental stressors, that's when these things can kind of take hold. But what if we stack conditions in our favor in the opposite direction? That's what your work is really about. And I'm glad that you brought this up with the exercise component. And you've been testing like we're talking about extreme environments to see what humans can actually do. And we can take on some of these things in our day-to-day life. So I want to ask you about this. And I know this is a tough question. All right. But this is one of those things that people tend to want to know is what are some specific things that we can eat that can support our resilience? And I'm going to throw one out here. Researchers at Auburn, so we're talking about neuroinflammation. They uncovered that oleocanthal-rich extra virgin olive oil was effective at helping to reduce neuroinflammation, specifically helping to heal the blood-brain barrier. I didn't have a dog in the fight. I didn't care if olive oil was remarkable. Or I got it. Like, I do have a bias because it's been utilized for so long and it's such a low processing method to make it. But the data, when I saw that, it's just like, there's something really special about this.
So olive oil, for the record, is my favorite fat. So extra virgin olive oil. I mean, it's rich. You get a good quality extra virgin olive oil, and it's rich in polyphenols. It has sort of a little bit of bitter and even kind of a maybe describe it as a hot taste. I have no less than always a quarter cup, so of a quarter to a half a cup of olive oil, I think, a day of rich, and that's a lot of calories. You work out the calories, and it's a lot, almost like 1,000 calories of olive oil. I'll make dressings, with it as the base, and I'll also put MCT, so it'll be like an MCT olive oil dressing. So you're getting ketogenic fats on top of the olive oil. Yeah, there's many foods that we just don't shouldn't necessarily, and this is an issue with the ketogenic diet, was that the classical ketogenic diet was a 4-to-1 ratio in grams of fat, 4 parts fat to 1 part combination of protein and carbohydrates. So 4 parts fat, if you work out the math, the percentages, it's something like 85 to 90% fat, right? It's a classical ketogenic diet, so used for epilepsy. An issue with that is that no consideration was really taken to consider what types of fats were part of the diet. So it was like mostly saturated fat, dairy fat, and even hydrogenated fats back in the day. And it still worked even with all that. But we have so much room for improvement in the types of fats that we're incorporating into our ketogenic. And aside from ketogenic, let's just talk about low carb, because the ketogenic diet is really a medical therapy. It's rather extreme. Let's just talk about a low carb diet, which is, maybe you call that a modified ketogenic diet, a 1-to-1 ratio, of fats to proteins and carbs. So extra virgin olive oil, monounsaturated fats should be the predominant fat in your diet. I'm not hypercritical of saturated fat, but if you can bring that down to like 20% or less, like the early ketogenic diets were almost all saturated fat, but if we bring that down and make the cornerstone of the fat within our diet monounsaturated fats, and olive oil being a large percentage of that, that's going to be super important. So oleic acid. So eggs surprisingly have very little saturated fats, and they're super rich in phospholipids and choline in vitamins. And so egg yolks are like eggs and fish and grass-fed meat, but even if you can't have grass-fed, just beef is fine. We tend to eat organ meats. We eat a lot of heart, and we eat a lot of liver, and I eat a lot of small fish like sardines, and have a lot of mackerel. So that's what I had this morning, mackerel. And nuts I use to some extent, but not a whole lot. If I eat a lot of nuts, I think just tend not to settle too well. But yeah, so at the cornerstone of the fat composition in a low carb diet, a ketogenic diet, should be monounsaturated fats, and also a higher percentage of omega-3 fatty acids. And when you look at the omega-6 to omega-3 ratio, you really want that to be, I mean, the modern diets are something like, I read 20 to 50 parts omega-6 to omega-3. Like, it's highly skewed towards
Crazy.
these omega-6 pro-inflammatory fats, where you should kind of, I mean, some authors talk about 5-to-1, but I mean, when I did the math on my diet, it's more like 3-to-1, some days almost 1-to-1. So if you could do a 3-to-1 omega-6 to omega-3 ratio, I think that's great. I mean, if you could do like a 1-to-1 ratio of those fats. So docosahexaenoic acid, like DHA and EPA, are super important for biological membranes, our immune system. They're basically like taking a low dose NSAID drug, but they have many benefits on top of that. And so yeah, so when you talk about specific foods, fish and eggs should be top of the list, and organ meats should be thrown in there, beef, and chicken. I kind of prefer turkey. We eat wild game like a lot at our house, but with fish, you have so many different kinds of fish, too. So you can do shrimp, you can do oysters and mussels and things like that. And there's just you're getting things like selenium, which are super important not only for detoxification but for antioxidant enzyme systems, things like that. So you're getting a lot of micronutrients that you would otherwise not get if you're just eating like chicken and broccoli or whatever. So I'm a huge fan of broccoli, so too. But yeah, and then let's talk about carbohydrates, what you can and can't have. I'm a huge fan of when I think of carbohydrates, I just think of fiber. So fat, protein, and fiber, right? So the protein can come from the sources that I was just talking about. But green leafy vegetables, the more green and darker, the better. And you're going to get that chlorophyll. You're going to get micronutrients. And, salads that are rich in colors. Broccoli. I'm a huge fan of broccoli and broccoli sprouts. Chlorella and spirulina are two supplements that I often take when I'm traveling and I don't have access to like eating salads or things like that. When I lived in the undersea environment, one of the things, because I knew I was in a high oxidative stress environment, the partial pressure of oxygen was higher and things like that. I couldn't have salads or fresh vegetables, so I was taking energy bits, which is a spirulina and chlorella supplement, but it's highly very dense in that. So and it's rich, and you're talking about a food that's functioning as a very powerful antioxidant supplement, and it's also a form of protein. So when we go to space exploration, we have to build bioregenerative systems to grow these vegetables that are going to be super important. Broccoli, spirulina will be super important things to incorporate into the diet, in addition to protein sources that need to be engineered and figured out too.
What's so interesting about spirulina, for example, is that NASA
Yeah,
actually kind of pressed it back into popular culture. This was in the
absolutely.
1980s when they were initiating research that it could be a nutrient dense source of nutrition for astronauts, right?
Absolutely. Yep.
So,
Yep.
and the crazy thing is, of course, it's been utilized for thousands of years
Yeah.
as a protein source from cultures in different parts of the world, whether
Yeah.
it's, South America or Africa. And
Yep.
to have it be like a potential space food
Yeah.
really speaks volumes about the nutrient density.
It does. Yeah. So yeah, not only is it a source of protein, but it's a can be a source of omega 3s, and it has a super rich array of antioxidant compounds that can offset the oxidative stress environments. And that's why I, took spirulina energy bit supplements, in that. And I would, ideally we want to be able to grow our own, like, in space. The former director of NASA Life Sciences, Dr. Marshall Porterfield, is actually spearheading a huge project in bioregenerative farming at Purdue, and creating like a big biodome facility where a lot of these regenerative technologies are going to be employed to basically design, engineer, and optimize the life support and food systems in space. So yeah, he's a good friend of mine, and really spearheading this whole regenerative ag thing that's going to have profound implications in space. But like many technologies that are developed by Department of Defense and NASA, or DARPA, like GPS, which got me here, are the public is going to use. So the public is going to benefit tremendous from this kind of research in regenerative ag. And I'm excited because I grew up on a farm and we live on a farm. I'm a neuroscientist, but I'm a kind of a farmer deep at heart. So I'm super interested in
Yeah.
these agricultural technologies.
This is one of the things that it really stands out about you that I admire is the fact that, again, you being somebody who's living on a farm and you
Mm-hmm.
putting yourself into these extreme environments as well, whether it's underwater, whether it's, knocking on the door of being in space and, putting these things to the test, but also educating and sharing what you learn. Right now you shared, you got two continuous glucose monitors on.
I do. I got an Abbott Libre and a Dexcom G6 on the other end. So I'm comparing the two as far as accuracy and precision,
Yeah.
and also reliability, because I bang around outside and do a lot of physical work outside. And
Yeah.
sometimes other ones are more prone to being knocked off
Yeah.
than the other. So vetting it out is important, vetting out these technologies.
And so both of us are big
Yeah.
fans of Levels as well.
Oh,
And
yeah.
they've got such a great the reason that I love them, one of the reasons is their data points in their
Yeah.
collection and being able to kind of stratify that for us to take those little pieces, like what are some of the most likely kind of culprit foods out there,
Yeah.
and things of the like. And also, by the way, guys, levels just opened up because they were in beta
Beta for a long
for a
time.
long time. They just
Yeah.
opened it up where you can get access now, and they've got a new version of it where you don't have to check in with your phone. I don't know if you know about
Yeah.
this. So
Yeah.
it just,
Yeah.
of
Yep.
course you know, of
Yep.
course you know. Anyways, go to
Yeah.
levels.link/model. That's levels.link/model. The waiting line is over. You can get access right now. I just got a new
Yeah.
one at home, and then
Yep.
seeing you're
Yep.
doubled up. So now I'm like, I'm definitely gonna go
Yeah.
today or tomorrow and put on the new one and give it a trial run. I learned so
Yeah.
much just getting that feedback, even from, different times of day, stress levels, all the things. Of course, we
Yeah.
attribute it towards our dietary intake, but it
Yep.
can provide us with a wealth of information you can have right there in your hand. It's personalized for you.
Absolutely. Yeah. And, that's why I partnered with Levels. There's a lot of CGM companies out there, but they were, and I've, talked with all them prior to sort of being an advisor for Levels, that they were super interested in improving the existing technology. So through research. So they were going to, put money behind research and determine and do as much research as possible to optimize their product as a tool for metabolic optimization. And we are specifically using continuous glucose monitors and the Levels app as a behavioral tool to influence the behavior around eating choices to optimize your diet. And this is in non-diabetics. We have a registered clinical trial looking at non-diabetics. And I think that's where this really comes into play. And I even know, insurance companies are really putting money into this idea that if you have a whole family history of, and everyone over 50 has type 2 diabetes, then people within that family at the age of 30, 40 or whatever should have a continuous glucose monitor to preemptively monitor postprandial glycemic excursions, if you want to make it scientific, and glucose fluctuations in response to meals, and so that individual can make better choices on the types of foods they're eating, on the amount of food that they're eating, and they could, insurance companies can pay a lot of money later, or they can pay a little bit of money now and actually reimburse patients who have maybe predisposed to diabetes. So I think this is like a super important thing, but people, they don't have to wait for their insurance companies to cover it. I mean, this technology is available through Levels, and most importantly, a CGM just gives you your glycemic variability throughout the day. What the Levels app does is it gives you highly actionable information and tells you what to do, and you get a metabolic score that is part of a complex algorithm that looks at the rate of rise, area under the curve, complexity analysis of the CGM trace, and all these things that will give you actionable information about what you should eat and shouldn't eat, and even exercise and sleep. All this data is sort of incorporated into the app. And it's been very insightful for me. I consider myself a pretty insightful person when it comes to choosing, but there were some foods that I thought I knew I didn't quite feel well after I've eaten them, and the CGM really elucidates and clarifies why that's the case.
It's fascinating,
Yeah.
especially again coming from somebody like you, getting that stamp of approval on that is remarkable. Again, that's levels.link/model.
Yeah.
And man, it's so awesome talking with you. And, I just really appreciate the work that you're doing and the way that you're going about it, because it's important. Like right now, we have an opportunity to help shift culture, and you're
Absolutely.
involved in so
Yeah.
many different areas of that. And if you could, can you let people know where they can follow you, where they can
Yeah.
get more information, and just
Absolutely.
get into your world?
Well, thanks for asking. Yeah. So I really appreciate what you're doing in the podcast world and bringing your expertise and information to a huge audience, which we have. Our lab was super motivated for educational outreach, as you have been, and we created the Metabolic Health Summit. So I'm a co-organizer for that, and that was in Santa Barbara a few months ago. Rhonda Patrick was one of our keynote speakers, as was Jung Ro, who got me into this whole field. So I would encourage people to go to Metabolic Health Summit. We offer CME credits, and you could do that. And there's a lot of content that's still there that you can get educational credit for. And I think that content will be available until October. So everybody in the space, so many people that many of your listeners are familiar with were speakers at this event. So Metabolic Health Summit, please check that out and the content that's available, because we had a whole virtual platform. And my website is ketonutrition.org. Keto Nutrition, all one word, .org. And we have a blog every 2 weeks on different subjects. The last one was on lean mass hyperresponders, why people get elevated LDL cholesterol on a low carb ketogenic diet, which is the question I get asked most. So check out that blog. And we also have a newsletter. So please sign up for our newsletter at ketonutrition.org. And I send you things in advance, sort of the cutting edge products that I'm using, I'm testing, and different science or podcasts that I'm doing. So this podcast will go into our newsletter and sent out to all our subscribers. And I'm excited for that to come out and share this information.
Hey, if you like this video, make sure to check out this video right here.
And you see that your blood sugar goes up 80 points, which would be a really high rise. You can say immediately in one time of just checking this food with your continuous glucose monitor, this food is likely causing a big insulin surge in me. And we know that one of the many functions of insulin is that it blocks fat burning in the body.